Alright guys, in 7.1 we're talking about the area between two curves. So let's say we got two curves. One's f of x and one is g of x. And we're going to make them any random curve. So I'm going to make f of x do something along the lines, maybe like that. And then g of x will be down here in green, and it'll do something along the lines of this. Now, when you normally find the area under the curve, if you're looking at the area under f of x's curve, we're looking at all of this shaded region down here. And then we have a negative shaded area here. The problem is, when I'm looking for the area between two curves, I'm wanting just the total area here and the total area here. So what we're going to do, it's going to sound easier, it is easier than it even sounds, is we're going to really just take top minus the bottom. So if I wanted this whole area, f of x, between these two curves, we really got to break them into two spots. Because in this first area here, and let's make this go, we'll have a couple endpoints. We'll have from A, this will be B, and this will be C. I'm marking where either we have the end of our interval or the endpoints where they intersect. So we're either going to be given those or we're going to have to find them. So between A and B, f of x is above g of x. So if I take, we have some area here for g of x as well. So what we're really interested in is all of this area here that's between the two curves. So we've got the f of x area up here, and then we want to add in the g of x area down here. Now the problem with just adding them is this g of x is below the x-axis, so that means it's going to be a negative area. So what we're just going to do is we're going to take the f of x area minus the g of x area. Now in this little area right here, f of x minus the positive g of x will cut out this positive g of x area and just give us the top half. So we really just have to do, let's do some red, I don't know why we would like red. We're going to have a couple different intervals. From A to B, we're going to take the top, which in this case is f of x, minus the bottom, which is g of x. Yeah, let's keep everything color-coded here. G of x. All of this is always times dx. So we got that. So this is going to give us the area of our first little piece. Now all we got to do is we got to add in the area for our second piece. But what happens is they switch. The g of x is on the top and the f of x is on the bottom. So we're going to add this plus the integral from b to c of whichever one's on top first, which in this case is g of x, minus our bottom, which is our f of x. dx. So what you have to do is you have to make sure you have a good picture, either using your calculator or drawing out by hand, and then you have to figure out which one's on top and which one's on bottom. Now sometimes there aren't different bounds. Sometimes there's just one set of bounds, but that's the main part here. So let's take a look at what it looks like in our actual notes. So if we want to find the area between these two curves, the first thing we got to do is we got to draw them out. So we'll let the first one be in red, so that's up 3, and we got a parabola opening up. So something along the lines of for this. So there's my one curve. Here's my next curve, starts up 1. And it goes down 1 over 1. So as we'll notice, these aren't really going to intersect each other. But the good news is we've got more curves to go with. So 0. And 3. This one's nice because it tells us all of the x bounds. So we're going to go from 0 to 3. And I've got a phone call in the background, of course. So we're looking at our area, which is top minus bottom. We're looking for all of this area, that bounded area. So, and you can talk about this area here, but it's not bounded by all of our graphs. So we're really looking for all of this area. So we're going to take the top minus the bottom, and we've got it. They're trying to sell me some sort of credit card. So,